Hello, good day viewers. In this tutorial, we are going to integrate the function the absolute value of 2 minus x with respect to x from 0 down to 3. I'm going to show you two different ways to do that. Let's start with the first method. Remember that if you have the integral from a to c, for example, of a function f of x, you can equally split it into the integral from a to b of the same function, then plus the integral from b down to c of the same function. Because we know that absolute value function in general is a piecewise function, and hence we have to split it, because the input 2 minus x could either be positive or negative. It depends on the value of x. So this is how we're going to split it. The integral from 0 to 3 of the absolute value of 2 minus x dx is equal to the integral of the positive version, which is 2 minus x. We assume it is positive with respect to x, then plus the negative version, that is negative of 2 minus x dx. But what about the boundaries? We have to assign values here that will make this positive. And you should know that it depends on this x value, right? So 2 minus what? From 0 to 3, because the interval is from 0 to 3. So which value of x from 0 to 3 will make this positive? It has to be less than 2 or equal to 2. Because if it is 3, we have 2 minus 3, which is negative 1. So we have to start from 0 and stop at 2. Then we begin with 2 and stop at 3. So this is what we need to integrate. And you know you can distribute this negative inside or you factor it outside. It doesn't matter. So if you integrate 2, it will be 2x. If you integrate x, it will be x squared divided by 2. So we have minus x squared divided by 2. Boundaries from 0 to 2. Then I can bring this minus sign outside. We have minus. If you integrate 2, you have 2x minus, you integrate this, you have what? X squared divided by 2. The boundary from 2 to 3. So now let us substitute the boundaries. Starting with 2 here, you plug it in here and here. So we have 2 times 2 minus 2 squared divided by 2. Then you subtract the lower boundary, minus 2 times 0 minus 0 squared divided by everything here will be 0. So let me just write 0. Then minus. If you plug in 3 here, we have 2 times 3 minus 3 squared divided by 2. Then you subtract the lower boundary, 2 times 2 minus 2 squared divided by 2. Let's simplify. You can see that 2 squared is 4, divided by 2 is 2. So we have 4 minus 2 here, minus the whole of this. This is 6. 6 minus, this is 9 divided by 2. 9 divided by 2. Then minus the whole of this. Let me put a bracket here. 2 times 2 is 4. Minus 2 squared is 4 divided by 2 is 2. 4 minus 2 is 2. Minus the whole of this. 4 minus 2 is 2. So we have 6 minus 2 is 4. Minus 9 over 2. 2 times 4 is 8. 8 minus 9 is negative 1. So we have 2 minus negative 1 over 2. If you open that, you have 2 plus 1 over 2. And this is 5 over 2. And 5 over 2 is said to be the solution to this problem. But let me show you how to do that geometrically. First of all, let us graph this function, the absolute value of 2 minus x. And our point of interest is from 0 down to 3. Our point of interest is from what? 0 to 3. So we start here. Let's assume this is 1, this is 2, this is 3. Let's assume we have 4 here. we have 1, we have 2, we have 3. So the graph of the absolute value of 2 minus x will pass y-axis at 2. So it will start somewhere here, something like this, something like this. So this is how the graph of the absolute value of 2 minus x looks like. So we want to find the area under the curve from 0 to 2 and from 2 to 3. So let me demarcate it. So this shaded region, you can see that these are two triangles, right? So let's find the area of these two triangles. The first one, the base is 2 units, the height is 2 units. So we have this particular area to be what? Half the base times the height. 2 times 2 is 4. Half of 4 is 2. So the area here is nothing but 2 units squared. What about this one? You can see the base is 1 unit. The height is also 1 unit. So we have what? This particular area to be half base times the height. 1 times 1 is 1 times half is still half. So to find the total area, we need to add this 2 and this half together. And this will give us 5 over 2 exactly, which is the same thing with this one, right? Thank you for watching. Do share to your learning colleagues and don't forget to subscribe to my YouTube channel for more exciting videos. Bye-bye.